to share my information extraction with Python. So at the beginning, we wonder what application of information extractions. I give some example like word segmentation, and other is QA systems. Word segmentation, for example, if I want to calculate how many times of occurrence New York Museum, but in our Python program, when we read the string into Python, and we will use split function, and the function will split this string into New York and the museum. But I actually want is the New York Museum, so this can count the right answer. So if you use information extraction, you can get this right string. So you can also get a more accurate segmentation result. And other example is QA system like Siri or Watson. In these pictures, it's a guessing game. Host will ask some questions, and this participant must answer the questions. The questions may like this: who is Bram Stoker? And this participant must answer these questions. So we may wonder how computer know the answer. No answer. So give example, we can ask the computer which country is access in, and computer may give answer as Greece. But we want to know how computer know this answer. Computer may query a database. So in your database, there may have a table look like this, have 3 columns, city and country population. So Greece is a country, and it has a city's Athens. Spain is a country and have a city Barcelona. So you have this table in your database. So give an example. So I use NLTK package and I import a parser, a grammar parser. So I load this parser and I give a query. What cities are located in Greece? We will pass this query into SQL. The SQL look like this. Select city from city table where country equal Greece. And you can use this SQL to query your database, and you can get the answer. So we need to establish this table. So our task is track the entity to database. The entities mean person or organizations or location or many. So how can we extract these entities from a lot of unstructured data and process this entity and process it to structured data and store them to your database? So question is how to extract. So in next slide, I will introduce what is conditional random field. It's a statistical model. In next slide, I will skip all the formula just to give an example. For example, I have a sentence. This sentence: Melbourne is a city in Australia. So I have this sentence. And now I know Melbourne is a location, and Australia is also a location. EFE is an organization. So now, suppose we don't know all these labels. We just given a sentence. So now we need to predict the label. We need to train a model to predict these labels. Before we train a model, we must give a part of speech. Part of speech is like, for example, I play basketball. Play is a verb. Basketball is noun. So this is POS, a part of speech. So sentence, and we give each word their part of speech. And now we want to predict Melbourne which label of this word Melbourne it is a location or organization or other. So now we want to predict this label. We need some information. The information can be from Melbourne, this word itself, and its nested word, and their part of speech, POS. So we can use this to predict this label together. And for nested word, the left bracket, we can use in same way. We can use this word itself and his previous word and his next word and their part of speech to predict this label together. Next word is the same way and so on. Yes. So now we already predict all these labels, so we can extract these labels. This word, Melbourne is a location, Australia is a location, EFV is an organization. We can process this word and store them to database. So now we want to write the program implement the CRF model. We have some open source tools like CRF++ and CRFsuite. This is CRFsuite. Its author is Japanese, and CRF is written by C++ and very easy to use. But in my practice, I always use Python to train this model. So we can use this package, Python CRFsuite. You can use pip to install this package. So let's see an example how to use the package. You can go look this IPYNB, the author, and try this IPYNB by yourself. And next slide, I will explain what IPYNB is doing. So before we training model, we must prepare our data set. So we can from NLTK import this corpus. CONLL. It's a conference. It's named Conference of Natural Language Learning 2002. And in this corpus, I have many data. ESP is Spanish data. NED is Netherlands, Holland. So we have test data A, test data B, and training data. And we use Spanish data. But you may want to use your own data to train a model. So you can annotate your data by yourself. I will recommend a tool, annotation tool, BRAT. It's a online collaborative text annotations. You can annotate by selecting text. I think I give a demo directly. This is web page, and it have many features like this. You can select the text. However, you can click this try BRAT online, and there have his username and a password. You can copy this. And we select the Spanish data, CONL 2002, and ESP Spanish data, and I select a document. So this is the data. So if you think this word is a location, you can select, and you can choose this label, location, and OK. So this word is a label as a location. If you think this is a person, you can click OK. Then you will label it as a person. Yes. Oh. And if you finish your annotations, you can download this file. Download as a tar.gz file. So this is a navigator. It looks like this. And if you complete your annotation, you can download the file, and it will look like this. For this string, it's a person name, and it starts by position 4. P is 0, 0, 1, 2, 3, 4. V is at position 4, and 17 is NES is at position 17. So you can read. So you can read this file to your Python and help when training our model.
So why are the countries of organizations?
Huh?
Are the countries of organizations, not locations?
Yes, but country is also location. We can you can annotate this tag by yourself. So now we have a data. So how do we train a model to predict person or its organization or locations? So next is feature generating. They have a function word to features, but we can look the figure in right hand side. This feature is like earlier slide. If we want to predict what level of Australia, so just we can use his previous word and his next word to predict the label together. So in this box, it means we get information from his left word, this left bracket. And in this box is get information from Australia's word itself. And this box is mean get information from this word. And you can see I is the index of Australia. So its next word must plus 1. And this word is lowercase, and its title is upper, and is POS tag. So we can look detail in next 2 slides. So however, this function is get all information from to help us predict this label. So give an example. If we input this sentence and we want to predict this label of Australia, the red line, Australia's lowercase, and his last 3 character is LIA, and his last 2 character is IA. It's not an uppercase, but it's title. A is uppercase, and it's not a digital. His POS tag is NP, and first 2 characters is also NP. His previous word is left bracket, and is not a title. His POS tag is FPA, and his first 2 characters is FP. And this is right bracket. FPT POS is FPT, and first 2 characters is FPT. So if you give this word, he will generate its feature like this. So we can use this function to generating a feature. So we use for loop and put all the sentence to this function, sentence to feature. So and it's a sentence. So we can use for loop get all the words, and put this word to features generate the feature. So if I give a sentence, the feature look like Melbourne, left bracket, Australia, and his last 3 characters is RME, last 2 characters is NE, and his upper title post tag. And because it's a first word, so it have not the previous word, so we give a tag is BOS, and his next word is left bracket, and it's not title, it's not digit, it's not upper, and it's the network POS tag is FPA and FP. Yes. So it will look like this. So when we finishing feature generating, we can train this CRF model. So we can declare the trainer and put the features training data. X is feature, Y is label, like locations, organizations. So and append this feature and the label to the trainer. And in this line, we will train the CRF model and save the model to your disk and give it a name. So after you training the model, you can make prediction. So you can open the model, read the model to your Python, and give a test sentence. The sentence, we can print this sentence. It will look like this line, this sentence, and this test sentence, and we transfer this sentence to features and use tagger predict its label. So the predict result is look like this. Locations. B is beginning, I is middle, and or ending. So these two words is a location, and EFE-con is a organization. So how about Chinese? We already know how to training and predict the model by Spanish test. So how about Chinese? It's difference in feature generating. Suppose we have a corpus, people's daily. You can download this corpus from Google. And this corpus is annotated by some expert manually. So and this is one document. And each word have a tag. Like T is time, and NT is organization. So this string is also organizations. NS is a location. So Taiwan is a location. Auman is a location. I give a very easy example. If you want to train a more accurate or complicated, more accurate model, you can search keyword to search some paper, and you can learn how they generate their features. Have a sentence like this. You can use Python split function to split this string to list, and so you can get this list. And you can use replace functions to transfer this tag to its organization. B is beginning, I is middle, and or ending. So suppose now we only have this sentence, and we want to predict these labels, part of speech, and next step we must tag their part of speech. So just like earlier slide, we say if you want to predict this label, you can use this word itself and his next word and their part of speech to predict this label together. Next word is the same way. You can use previous word and the next word and their POS tag. So you can use the same way to predict all these labels. So after you predict all these labels, you will get organization beginning, eyes, middle, or ending. So you can extract this string and combine them into a string and store them to your database. I will tell you. Thank you.
So are there any questions?
Yeah, I'd like to ask if there is any ongoing effort of making CRF to be more accessible. As far as I know, the PRFs, the Python CRFsuite and the Python wrapper for Stanford NER is severely lacking in documentation, and thus making it hard to us for us there to do something other than toy language, toy program. That is the same with the example.
Example. Can you speak your questions? Repeat. I can understand. I can understand your question.
I'm sorry because currently there are severe lacking of documentation on Python CRFsuite and Python wrapper of Stanford NER with CRF method in it. And I'd like to know if there's any ongoing effort of making it more accessible to us to use the API.
Self locations. Do you mean have we have any other example to help us to predict to training this CF model?
I mean, yeah, that's for one. And another thing is the API is not well documented because it only tells you this is the function and
Yes.
this is how you call it. And there's no more than that other than telling you to read those paper behind firewalls. Yeah.
Because CRF model, you not use Python CRFsuite, you should search the CRFsuite is official document, but they have some tutorials. You can load this document, and you can learn how to. In this document, there have some explain to how to give your corpus or generate their features. Because it's a complex model, when you want to train this model for Chinese, example for Chinese, you just can only search a paper and learn how to extract the features, because they have a fewer document for explain how to generate the Chinese corpus. So I think this Python CRFsuite, its example is it's very easy to understand, because this document is too deep. It's too difficult to read. So I have seen the easiest document is just the Python suite. This package's document is I have seen the easiest easy to understand easy to understand. Sorry. We can discuss these questions at a break time.
Hi. Thank you for. I'm at the first row. Yeah. Thank you for the wonderful talk about this. And I'm curious. I have a simple question. I'm curious that if you have a word that is both location and what label do you have? And it has different labels, like Sydney. It can be a name, and it can also be a location. So how do you handle this kind of difficulty, I might say?
Difficulty. Do you mean can we tag a label by ourselves? Means not only the location or organizations. Can you mean we can tag the label like brand or music or other people's name or others?
Well, that's a very good question, but that's not quite mine. So, how to say? When your code is identifying, when you are identifying the feature to label. For example, you have Melbourne to location. So during this process, you have to identify this, right? But there are some times that like Sydney could be location, and Sydney could be a name. So that how is your program handle this kind of scenario?
Because the locations, their previous name and his next name were very different from the person's name. Person's name's previous word and his next word is different from locations.
Oh, okay, I see. Can I ask another simple question? Okay, so when you are saying this, that means that you have to study the structure of the language, right? So that you would know, okay, the pre-use word should be something, and the afterwards should be something, right? So I'm curious, how do you study this? How do you gain the knowledge of this, for example, the structure of the language?
Do you mean how I learn? How I learn? Which word is mean? Can you speak?
Yeah, sure.
我用中文讲哈，因为那个
Yeah.
英文有点我不知道怎么讲那种东西，就是因为我们通常你预测出来那个地名之后或人名之后啊，就是你会直接去抽取它前后几个字出来以后，然后你才去看说哪一些字可能是地名，它在很前面的，它的前后文是排名在很前面的那样子。对，那所以说你就可以用那些特征，然后再下去找说可能其他的地名还有哪一些类似的字这样子。如果你有兴趣，我们可以等一下再继续讨论，因为这个有一些专业名词我不知道怎么用英文表示它。对不起。
Thanks for the nice illustrations you gave. It's very clear and concise. I have a question. You mentioned that for the different languages, you created a different feature engineering process. What I'm curious to know is, do you have like a system in place where you can generate just one model to predict for all languages, or is this possible, or is there any effort going on to just create one model and one feature engineer for all the languages? Is that possible?
CF model, just like in the Spanish, it's different. It's different in how you can use one CRF model, but you should generate the different features. Like Spanish when use the is word is upper or is title or is POS and letter 2 character or 3 character. But in Chinese, the structure is different. Suppose I give an example. The Chinese is locations. In my prefix is person's name. Like something like 讲中正纪念堂那样，中正纪念，中正 is a person's name, so its location will also contain some person, and other organizations that will also contain some person's name or other location name, like 蒋中example 张荣发什么万华区什么纪念中心 like this. So you should generate a feature from the person name and predict and use the person name result predict the location's name and location's tag and use these two tags and then predict the organization's label. So you should generate a different feature from each step.
Okay. Okay, so there has to be some extra effort to, if you want to maybe do another language, you have to do another extra effort. That's what I'm saying. Maybe there is a better way to create a model that can suit for different languages instead of creating the features over, and it becomes very repetitive, I think, because you are using just a position, right? So the position is what is what you're using to create the features, but maybe there is some other way to create better features. It's just a comment.
Oh.
One more question from there. Do you have any questions? Yeah.
So to follow up on the girl's question, I give you an example. I visited Sydney last week. What can you say? Can you give a probability or give a definite answer?
Can you repeat again?
去拜访了一个人，还是去拜访了这个地方？因为 Sydney 可能是名字，也可能是纽西兰的那个澳洲 Sydney。
When you want to solve this problem, you, 没事，对啊。
Actually, that depends on the context.
It's like I visited Sydney last week, and she shows great hospitality. Then it should be a name. So your natural language processing program should do the full context, the full paragraphs in a whole, and I think you can do it, of course. And many kinds of tools or NLTK also do this parsing. I believe so. So it's not gonna be a question.
So are there any other questions?
Okay. I'm very interested in your shopping website. Have you used technology to identify such as product name or price?
Product name or price. Product name is feature like a product brand. They always have a left bracket or right bracket to in this previous word and right and next word, and always a brand that always have a digit because it's you can use Python. It's digit this function to generate feature is a digit, and have many other features like bracket, right bracket, and some many brands that their English word is uppercase. So when we predict a product brand or price, the features many similar to just Spanish text.
Okay, thank you.
Okay, so because of the limit of time, let's thank the speaker. Okay.